Today we're going to be learning about how we find slope. We're going to start with an example in the Cogwheel Railway. The Mount Pilatus Railway in the Swiss Alps is the steepest cogwheel railway in the world. The track rises about 20 feet vertically for every 50 feet it runs horizontally. How can we describe the steepness of this track? So we're going to show a diagram. Right here. So for every 20 feet that it runs, for every 20 feet that it rises, it will run 50 feet horizontally. Okay, so it's the steepest one that we know. So we can describe that as a ratio of rise over run, and that is our slope, because slope describes the steepness of a line. It is also the rate of change. So if you have 20 feet over 50 feet, go ahead and reduce that, simplify that, and you would have a slope of 2 over 5. And that would be your answer. So we're going to be looking today at the ratio of rise over run. Note that our rise is a measure of the change in the y-axis, and our run is a horizontal change or change in our x-axis. So let's look at some different types of slopes. To find the slope of a line, if you look at a graph, you can identify 2 points. Those 2 points have ordered pairs. So we're going to take a look at the change in the rise over the change in the run. Okay, I'm going to go ahead and mark this on. So the change in the rise goes straight, that amount of change. The change in the run, right here. So if you count or look at the y variable, you have from a positive 7 to a 2. So you would show this as the change in y as 7 minus 2. We're just looking at the y coordinate. The change in x is from 1 to 5. So 5 minus 1. Now the reason I chose to do it this way, since I looked at this point first, I used the 7 in the first location, and then I used the 5 in the first location. Okay? So you always want to be using the coordinates in the same order in your numerator and in your denominator. So if we have the rise would be 5. 5 minus 1 is 4, so our slope would be a positive 5 over 4. So let's take a look at the notation that we would use. So again, you have 2 points, y2 minus y1. Those subscripts are just telling you the 2 different ordered pairs you're gathering that information from. For x2 minus x1, again, notice that we're using the same ordered pair. So when you're looking in your ratio, you should see the x and y from the same pair. You can't mix and match them. So we would substitute in the information that we have, and we get our slope, and it would be a positive slope. So notice how it is going and pointing, I'd say, up in a positive direction. That's our positive slope line. Okay, so anytime you have a positive coefficient of x, you would have a positive slope or a line that would run this way. Looking at this line, it runs the opposite direction, so this is actually a negative slope. And again, we would do our rise over run, and our 2 points, y2 minus y1, x2 minus x1. Okay, and it looks to me like they're just selecting the points. It really won't matter mathematically. It will work out either way. They are looking at the points left to right and calling them point 1, point 2, point 1, point 2, because you can see that using the 3 and the 4 is coming from this point right here. Okay, so for the point 2 to get the difference minus the point 1, which is up here. So if you take 3 minus 6 and 4 minus 2, notice that you would get a negative 3 over 2, or the whole slope fraction would be negative, and that is indicated also by the direction of the line. So what about 0 and undefined slope? Sometimes we'll come into contact with this. We did our horizontal and our vertical lines, so let's calculate our rise over run. Again, they're just going left to right, so if you want to just number your points, point 1, point 2, take the coordinates from that. Your change in y would be 3 minus 3, and your change in x would be 6 minus 2. So if you get a 0 divided by 4, right, that means that your slope, if you simplify that, you actually get 0. So that is a 0 slope line. There is no steepness, and that kind of makes sense. So that's a horizontal line. All horizontal lines have 0 slope. Okay, here's a vertical line. So again, you're going to calculate the difference here. So we have 4 minus a negative 2, which is going to be 4 plus 2, which is 6, and then 1 minus 1, which is 0. And you know that there's that you cannot divide by 0. It's undefined mathematically because there's nothing times 0 that would equal 6. So this slope is called undefined. So horizontal lines, slope of 0, vertical lines, undefined slope. So let's give it a try. Here's 2 points. Again, you can call the first one point 1, the second one point 2. You will be using the rise over run, which is the change in the y coordinates over the change in the x coordinates. So y2 would be 4, y1 would be 1, x2 would be 6, and x1 would be 2. Simplify, and if it's in a fraction, just keep it in simplest form. Let's try another. So this is a negative 3/5. And this one, oops, sorry about that. The last one was a positive 3/4. For our final example today, we're going to find coordinates of 2 points on this line with this given equation, and then we're going to use the points to find the slope of the line. So you have options. You could make a table. You could use intercepts. I'm going to go ahead and use intercepts because that was our very last lesson that we just did. But if you would rather work with some numbers so that you don't have some complex fractions, I'm going to have some messy complex fractions here, but it's just fine. Remember that if we're getting our y-intercept, then our x-coordinate is 0, so 0 plus 11. So the y-intercept would be equal to 0 and a positive 11. Our x-intercept would be when y is equal to 0. And in this case, if this is equal to 0, we have to get rid of the 11, so you subtract 11 from both sides. So the negative 11 is equal to negative 3x, and here's where it starts to get messy to solve for x. So we would have our x-coordinate equal to a positive 11 over 3, and our y-coordinate equal to 0. So putting this into, so we'll call, what do we want to call this? Let's call this, it doesn't matter, 0.1, 0.2. So we'll do, let's call this 0.2 up here. This is our 0.2, this is our 0.1, and the only reason we do this is so that we can set it up. So our change in y would be 11 minus 0 over, and we go back to the first one, which is 0 minus 11 over 3. So we have a complex fraction to solve. 11 over a negative 11 over 3. When you have a complex fraction, I would go ahead and simplify. So 11 times a negative 3 over 11. Remember, you're multiplying by the reciprocal. Nicely, though, the 11s cancel out, and our slope is a negative 3. That is our slope. Looking at the next one, our y-intercept is equal to 0, 7. Our x-intercept is nicely a 56 over 9, 0. So another complicated, messy one, but that's okay. You could use whole numbers. You could find something that would, simplify, but I think that that's more work. So if we're going to do the change in y, so we have 7 minus 0 over the change in x, 0 minus the 56 over 9. We get 7 divided by a negative 56 over 9. I'm going to go up here, 7 times a negative 9 over 56. I can simplify with these two numbers. That's going to be 1. That's going to be 8. So my slope is going to be a negative 9 over 8. So another negative slope there. Sometimes it'll work out that it will be positive. Just use 2 points. Again, you can find the 2 points from using a table or from using the intercepts. Just make sure that you complete the math until you get a simplified fraction.